1940. Nazi panzers were rolling through France, the Luftwaffe terrorizing European skies. In a cramped office in Inglewood, California, a 45-year-old engineer named Edgar Schmood sat sketching what would become the most decisive fighter of World War II. But here's the twist. No one had asked him to design it. The U.S. Army Air Corps hadn't issued a contract. They hadn't even hinted they wanted a new fighter. Schmood was operating on pure, calculated risk. If he got it wrong, his company would eat the development costs, and he'd be out of a job.
Born in Hornbach, Germany in 1899. As a child, he watched Wright brothers demonstrations in Europe and became obsessed with flight. After World War I, he worked for Fokker in the Netherlands, the same company that built the Red Baron's triplane. The Great Depression drove him to America in 1930 with nothing but engineering drawings and ambition. By 1936, he was at North American Aviation, a scrappy outfit building only trainers. They weren't Lockheed, they weren't Boeing. They were the underdogs.
April 1940. The British Purchasing Commission knocked. Britain was bleeding aircraft faster than factories could replace them. They asked North American to build Curtiss P-40 Warhawks under license. Safe, standard, quick money. But company president James Dutch Kindleberger and Schmood saw something else. An opportunity to leapfrog everyone. Schmood told the British rep something audacious. "We can design you a better fighter from scratch in 120 days. The Brits thought he was insane. His own colleagues thought he was insane. You don't design a combat aircraft in 4 months. It takes years, wind tunnels, prototypes, failures. But Schmood had been secretly refining advanced fighter concepts for months, obsessed with one problem plaguing every fighter of the era: range. Spitfire, brilliant in a dogfight, but out of fuel after 400 miles. P-40, decent range, but climbed too slowly. Messerschmitt Bf-109, lethal interceptor, but tied to airfields by tiny tanks. Every Air Force faced the same brutal trade-off: nimble or long range, but not both. Physics wouldn't allow it. Schmood believed the right wing could bend physics.
May 29, 1940. The British signed the contract. 120 days to first prototype. Impossible. Schmood assembled 150 engineers and draftsmen, 24-hour rotating shifts. His secret weapon? NACA data on a radical wing shape, the laminar-flow airfoil. He was betting his entire career that it would work. Not in a wind tunnel, but at 400 miles per hour, with someone shooting at you.
October 26, 1940. 178 days after contract signature. Test pilot Vance Breeze lifted the NA-73X prototype off Mines Field in Los Angeles. The plane felt light, responsive, eager. Rolls, climbs. On landing, Breeze grinned. "This thing handles like a sports car." The British christened it Mustang. Early reports validated Schmood's impossible gamble. 390 miles per hour in level flight. Smoother, more stable than anything in the sky. But early 1942 RAF squadrons revealed the brutal truth. Below 15,000 feet? Magnificent. RAF pilots used them for ground attack and recon, strafing German supply columns in France with devastating effect. Above 15,000 feet, the Mustang turned from thoroughbred to struggling cart horse. Engine wheezed, acceleration died. In a high-altitude dogfight against a Bf-109 or FW-190, it was a sitting duck. Pilots called it a low-altitude sports car trapped in a high-altitude war. The culprit?
The Allison V1710 engine. Single-stage, single-speed supercharger. Sea level, 1,150 horsepower. Above 15,000 feet, 900 horsepower. German two-stage superchargers maintained full power to 25,000 feet. Horsepower equals options: speed, climb, escape, or pursuit. The Mustang had beautiful aerodynamics, but a weak heart.
P-51s were relegated to low-level reconnaissance, screaming over enemy territory at treetop level, relying on speed and surprise. Humiliating for a plane that looked so promising. B-17 flying fortresses were being slaughtered over Germany. P-47s and P-38s had to turn back before deep targets. Bombers flew on alone. Luftwaffe fighters tore into them like wolves into sheep. Everyone knew the solution: a long-range, high-altitude escort fighter. The Mustang had the range, it had the airframe, but it did not have the altitude performance. Schmood's impossible design was dying of oxygen starvation. Ronald Harker, British test pilot for Rolls-Royce. April 1942, he visited Inglewood. Flew a Mustang demo. Instantly recognized. Airframe extraordinary, but gasping for air at altitude. On landing, he sent a telegram to Rolls-Royce HQ. Flight testing Mustang needs Merlin engine. 5 words. The war changed.
Two-stage, two-speed supercharger. 1,520 horsepower at 20,000 feet, nearly double the Allison. First stage compresses air. Intercooler increases density. Second stage compresses again, forces into cylinders. But swapping engines isn't like changing a car battery. Heavier, different mounts, cooling, propeller, everything redesigned.
By October 1942, they shoehorned a Merlin 61 into an RAF Mustang at Hucknall. First flight, October 13, 1942. Pilot, Captain Ronnie Harker. 20,000 feet, leaped forward. 25,000 feet, still climbing strongly. 30,000 feet, engine still pulling hard. Dive, 433 miles per hour. Landed and filed a report. Phenomenal, revolutionary. Britain designated it Mustang X, top priority.
November 1942, Wright Field received data. Speed, plus 50 miles per hour. Service ceiling, 31,000 to 41,900 feet. XP-51B flew November 30th, 1942. Pilot Bob Chilton radioed down. "This thing climbs like a homesick angel." The transformation was total. The same airframe that struggled above 15,000 feet now dominated 35,000 feet. Packard licensed the Merlin V1650 for mass production. Early 1943, P-51Bs rolled off lines in Inglewood and Dallas. Allison Mustangs reassigned to ground attack. The real Mustang, the Berlin Escort, had finally arrived.
Every wing drags air molecules across its surface. Normally, turbulent flow, tiny whirlpools, eddies, drag. Drag equals fuel burn just to fight the air. Schmood needed to eliminate turbulence. NACA 45-100 laminar-flow airfoil, Eastman Jacobs, Langley, late 1930s. Maximum thickness at 45% chord versus 25 to 30% on 1930s wings. Smoother pressure gradient, air flows in organized layers, laminar, longer. Wind tunnel results? 30 to 40% less drag at cruise speeds. But laminar flow is fragile. Surface must be perfectly smooth, thousandths of an inch. Rivet heads, bugs, rough paint, trip flow, turbulence. Schmood demanded 1940-level insanity in manufacturing. Flush riveting, plus minus 0.005-inch tolerances. Hand-sanded wings, wet-sanded paint between coats. P-51 internal fuel, 269 gal to 489 gal with drop tanks.
Combat radius, 750 miles. Spitfire, 340 miles. P-47, 475 miles. The beautiful part? Faster cruise, 280 miles per hour, less fuel per mile.
March 4th, 1944. 64 P-51Bs, 4th Fighter Group, Debden Airfield, England. Time, 10:15 a.m. Mission, escort 316 B-17s to Berlin. Distance, 1,100-mile round trip, into the heart of the Third Reich. No Allied fighter had ever gone there. Bomber crews didn't believe it. Every time, escorts waved goodbye at the German border. Lieutenant Colonel Don Blakesley led. Over the channel, thick clouds, icing. Some Mustangs aborted. The rest crossed into Germany at 27,000 feet, cruising efficiently. 11:40 near Brunswick, BF-109Gs and FW-190As dove in. German pilots hesitated. American fighters this deep? That hesitation cost them. Mustangs broke, turned inside, climbed above, dive attacked. Captain Don Gentile, 2 BF-109Gs in 3 minutes. Laminar wings held control where others buffeted. 12:15, over Berlin. Flak burst black through the clouds, blind fire. B-17s dropped bombs via radar and turned for home. Mustangs checked fuel, drop tanks empty, on internal. Straight lines home, no wasted maneuvers. 14:30, over the North Sea. 1500, wheels down in England. Results: 5 bombers lost, mostly flak. 5 Mustangs, Luftwaffe claimed 11. 13 German aircraft destroyed. The real victory? Psychological. Luftwaffe radios screamed, "American fighters over Berlin." Hermann Goering,
P-51D, 1944, bubble canopy. 437 miles per hour at 25,000 feet. Climb, 3,200 feet per minute. Merlin, breathing strong at 28,000 plus feet. Turn radius, 1,200 feet at 300 miles per hour, energy retained. Dive, 505 plus miles per hour, no flutter. Firepower, 6 times .5 cal M2, 1,880 rounds. Converged at 300 yards to 6-foot cone of destruction. 2-second burst equals 160 bullets. German aces, hundreds of hours, lost to American rookies because the Mustang made inexperience irrelevant.
January 1944 to May 1945. 4,950 enemy aircraft destroyed, 4,131 air, 819 ground. 8th Air Force bomber losses, 1943, 350 per month, 1944, less than 2% per mission. The Luftwaffe had to engage, but Mustangs were everywhere. Ground attack, locomotives, trucks, airfields. .50 cal shredded everything. Cost, 2,520 P-51s lost, approximately 1,300 pilots killed. But the exchange ratio, 1 Mustang equals 2 to 3 German fighters plus dozens of bomber crews saved.
Korea, 1950. F-51Ds pulled from mothballs. Ground attack from rough strips, heavy flak. Jets were fragile, runway hungry. Mustangs, 62,607 combat sorties, 351 lost. Israel, 1948 war, in service until 1961. Dominican Republic, operational until 1984, 44 years after prototype. Schmood's next step, F-86 Sabre, Mustang DNA, visibility, efficiency, range. Retired 1960, died 1985.
lived to see his 1940 Impossible design, still fighting 40 years later. Technical legacy: NACA 45-100 to supercritical wings. Boeing 737, 747, Airbus A320. Every time you fly long haul, you're riding Schmood's laminar-flow wing.
Sometimes the best solution is the one nobody asked for. One German immigrant engineer refused to accept physics limits. A 120-day impossible deadline. A wing that didn't cut the air, it slipped through it. The bombers made it to Berlin and came home because one man said, "We can." This wasn't just an airplane. It was a dream that took flight and never came down.